Good afternoon, everybody. We are going to do a demonstration of a gas recovery from an AC unit, and these are the tools we're going to need. You're going to need a manifold gauge set. We're going to need a recovery machine, a filter dryer, a recovery cylinder, a scale, an extra hose, and then extra little hose. And you can, core removal tools, and I have a video up about how to use a core removal tool. Will help speed it up. I'm going to do my demonstration today without the core removal tools, and I'm going to time the recovery, and then I'm going to do a second video with the core removal tools to determine how much faster it is, and if I can keep all the conditions the same. So, to get started, you want to have your machine off. So you do not want to be recovering on a machine that's running. I'm going to take my Schrader caps off. And this system is a 410A system. And it has, supposed to have the charge should be 54 ounces of 410A. So I'm hooking up my manifold gauge to the suction. Now, before you hook up, make sure all your hoses are tight and your valves are closed, which they are. I'll set my refrigerant to 410A. Not really necessary, but I like to do things the same way all the time. Repetition is the way to keep from making mistakes. Pretty much like, oh yeah, I forgot to do that. Okay, so I've hooked up my gauges, and I'm just going to go ahead and purge the air. I used to use the 2-second rule. 1 Mississippi, 2 Mississippi. 1 Mississippi, 2 Mississippi for the gauge set. So I've purged any air that was in the lines so far. So I've got my low side to the blue. I've got my liquid side to the high side to my liquid line. So liquid, little line, however you guys can remember it. So, and it's pretty much I call it the Gazinta method. It goes into here and then it goes into there. So here's my filter dryer. And we're going to need there's an arrow on the filter dryer for the direction, and you're going to be going out of the manifold gauge set and into the recovery machine. So I'm going to use another hose here, a little jumper hose. And that goes into the recovery machine. If you can see that, we have an in and we have an out. So then we need another hose coming out of the recovery machine and that goes into our recovery tank. Now before I hook up the tank, because the weight of the hoses is going to change the weight that you're reading. So I like to measure the bottle first, and because these recovery cylinders, my TW is my tank weight, and that says 17.1 pounds, and that's how much it weighs empty. So I put my refrigerant cylinder on there, and it's reading 17.0. So these weights can be a teeny bit off. If you have a big discrepancy, and it's a used recovery cylinder, that there may be oil still on the bottom. So I always like to weigh my empty bottles first. This one I pulled a deep vacuum on the bottle already, and so it's ready to go. And so I've heard a couple different ways. I don't think there's a real difference on whether you hook up to your vapor or your liquid. I tend to, it depends on how much refrigerant I'm recovering as well. So whether you put into the liquid port, then some people say the weight of the liquid slows down the recovery process. Other people say you hook up to the vapor side. I've never really found any appreciable difference in time, so I'm just going to hook it up to the vapor today. You can kind of hear the refrigerant going a little easier that way. Okay, and I also like to add a ball valve in line with this. So, and you can see, just with the empty hose setup, the weight of the hose, it changes as you move but it added 5 ounces to the weight. That's why I weighed the cylinder without any hoses hooked up to begin with. And so we're pretty much hooked up now. So we purged our lines up to here, up to our valves. Then what I'm going to do is unhook this bottle here, and I am going to open one of my service valves, and that's going to let the refrigerant come through the yellow, through my filter dryer, and it's going to push any air into the recovery machine and out of the recovery machine and all the way up here to the end. And it's about 5 to 10 seconds. Without running anything, you just the refrigerant will push the air through. And I kind of go by smell. If I smell the refrigerant, I think I've got it all purged out. And I'm going to open my valve here a little bit. Okay, so I can smell the refrigerant, so I think I'm good. And then I'll do one more little purge from here to there. Okay, so now, make sure all my connections are tight. There. Oh, that one needs a little tightening. Okay. So, I've purged all the air out of the lines, out of the machine, out of this hose, and all the way to my tank. So I've gotten rid of all the air, and I did my de minimis purge. So, with the tank and the bottle and everything set where I'm not going to touch it anymore, you can zero this machine out, the scale, and that way it's going to count up how much refrigerant you recovered, and but it's always a good idea to write it down what your starting tank, especially if you're using a tank that's already had some refrigerant in it, and there's just room in the bottle, in the cylinder. So these cylinders can only be filled up 80%. So this is a 30-pound refrigerant recovery tank, and so 80% of 30 is equal to 24 pounds. So I can only fill up 24, I can only add 24 pounds of refrigerant to this cylinder, then it's considered full. Because you need to have a gap between the liquid for expansion and contraction. When the recovery tanks get hot, the pressure increases, so it needs some expansion room for the gas. Okay, so now we are going to, you can see I've got 85 psi on each of the gauges. So I'm going to go from closed to recover, and I'm going to open up, I'm going to close this valve first. I like to do this, that way I open up the valve, and I've got a quick open close now with the ball valve. So, and I'm going to open up my recovery, my manifold gauge set hoses are open. That comes over through here, into here, and this is my recovery valve. So it's closed, recover, self-purge, and closed again. So, and it comes, oops, we'll go, there we go, kink that hose there. Then we're going to come out of the recovery machine into this ball valve and ball valve into there. So I'm going to go ahead and push the start button. And I'm going to open up this valve. And we can see that our weights are, if I move some stuff around, it'll change a little bit as these hoses are moving. So, that is our refrigerant recovery process. So, on this field piece style recovery machine, it is going to turn itself off when it reaches the required vacuum level, and then you go to self-purge and hit the start button again, and it will purge itself out into the tank. So so that's the basic setup how we do a vapor recovery on a system. And I'm going to go increase that valve a little bit. So if you're pulling some liquid through, you can throttle this valve to slow down the liquid so it gives the compressor a chance to doesn't have to work as hard. So we've already recovered 1 pound, 5 ounce, and a half an ounce. So you can speed up the recovery because what a recovery machine is it's actually there's a compressor and a condenser built into that. It's basically a remote condensing unit, and it will so it's going to add heat at compression, and you can add in, besides this, you can add in in line on your discharge a cooler, which will you can sit it in some ice or a bucket of water, and that will help cool down that gas, because the more you recover, this tank is going to get warmer and warmer, and then as it gets warmer, it's building pressure, and so it's going to slow down the recovery process because you're pushing against the pressure that's inside the cylinder. And so you can also, what I've done is I've draped some rags on the bottle with the water from a garden hose trickling on the tank itself. The one problem with that is if your the scale I had wasn't waterproof, so my scale stopped working until I dried it out. So if you're going to cool down the bottle with water like that, I would recommend taking it off the scale and intermittently checking my weight to make sure I don't exceed the limits. Here in this situation, we'll probably have 3 pounds of refrigerant in this. Whatever the 54 ounces is divided by 16, so it'll be about 4. So that is the only other caveat to that. So we are 1 pound 7 ounces now. And while you're waiting for this recovery, if I was on a service call and I had to recover the refrigerant, right now while I'm recovering refrigerant, and you never want to leave the system, you don't want to start recovering your refrigerant and then run off to lunch. So you want to be there and making sure nothing happens during the recovery process. As you can see, sometimes there's some vibration with the machine. A hose can come loose or vibrate loose and start leaking refrigerant. It could rain. There's all kinds of reasons why you do not want to just leave this unattended. So, if say I had to replace the liquid line filter dryer on this machine, I would be prepping cleaning up the copper. I would be getting my parts ready. I would getting my torch set, the tools, everything all in place. So by the time I'm done recovering, then I could get right to work instead of just sitting here staring at this, then prepping my parts. So you want to look busy. You don't want to be just playing on your phone. You could be doing paperwork though. So like I said, your time is money, and the more time you save the customer, the better for them, and the happy they'll be with you. And so we're at 1 pound, 8 ounces, 9 ounces. And the bottle is starting to warm up a little bit. Everything's looking good. But you can see it is starting to slow down now a little bit. One of the things that the company I used to work for, we started to recommend is that we're using a filter dryer to take the refrigerant out. That'll help get any moisture, non-condensables, and any particulate. But in addition to that, so that's going to protect your machine and your recovery cylinder from some contaminants. What we found is when you are exchanging refrigerant cylinders, not necessarily will, okay, so now my machine turned off and I'm at 6 inches of mercury right now. So I'm going to switch this to self-purge mode and I'm going to start it again. And it is going to take any refrigerant that's still in the condenser and push it out. Okay. Then I'm going to close my valve here. I'm going to push. Okay. And then I'm going to close my manifold valves. And I'm going to close my refrigerant tank. And then I close this valve. So that is our recovery. So we took out 1 pound, 9 ounces, and I started at 1432, and so 22 minutes it took to recover basically 2 pounds of gas. Okay, one of the other things I like to do, so my machine is recovered and I'm right at below zero. So when I do my repairs, I pretty much, what I like about this is having this hose here. If I was, say, recovering 100 pounds, I would have needed 3 50-pound cylinders. And so you could close this, disconnect my hose here, and then I can go right to another refrigerant cylinder. I just got to purge that little bit. If I didn't have this valve here, I would have to purge this whole line back to my recovery machine. So, in addition to that, say I made my repair, because there's going to be some loss when you recover a little bit, so you're going to have an ounce in each hose, and then maybe a couple ounces in the machine. So you may lose half a pound to a pound of refrigerant doing a recovery process. So that pound of refrigerant, I save it like this. So if I'm going to pressure test my repair, I'll put this refrigerant back, instead of just venting it to the atmosphere, I'll put it back in here as a test gas for my electronic leak detector. And then I would just use this, and if the pressure didn't come up high enough, then I would add some nitrogen to it so that way, otherwise you're just venting it to the atmosphere when you could be using it for leak testing purposes. So that pretty much concludes our refrigerant recovery process. Thanks for watching.